For 11, this negative 12 plus the square root of negative 40 over 6, I need to get it into two fractions. I also need to reduce that square root. And the square root of negative 40 is the same as the square root of positive 40, but times I. I'm going to do a prime factor tree for 40 to reduce it. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So 40 is 2 times 2 times 2 times 5. The square root of 40, I'll get a 2 in front of the radical and a 10 under the radical, because the pair of 2's goes in front, the 2 and the 5 that are singles go under. So this is the one fraction. All the pieces are reduced, and now I'm going to make this into two fractions. I'm going to make it negative 12 over 6 plus 2 square root of 10 I over 6. The first fraction, 12 divided by 6, is negative 2. The second fraction, I'm going to go 2 divided by 2 is 1, 6 divided by 2 is 3, and I'm not going to write the 1 in the numerator, because it's not necessary. And my calculator, if it was in mode 2, would never leave an I in the numerator of a fraction like that. Both of these are acceptable answers. I would frequently leave an I like that, but it's not really customary. Oh, yeah. 12 is multiplying two cube roots, just in case it's not readable. It's the cube root of 2a to the 9th, I'll emphasize b to the 1st, times the cube root of 8, a to the 7th, b to the 4th. I'm going to multiply the numbers and add the exponents on the letters and leave this a cube root. So it's going to be the cube root of 2 times 8, which is 16, a to the 9 plus 7, which is 16, b to the 1 plus 4, which is 5. So this simplifies to the cube root of 16, a to the 16th, b to the 5th. Prime factor tree for 16 is 4 2's. So when I reduce this, because it's a cube root, the 16, I'm going to get 1 2 in front of the radical from the 3 of a kind, and a 2 under the radical for the single 2 that's left over. The ridiculous a to the 16th, oh gosh, when I go to write it down, writing down 16 a's if I have the patience, I'm running out of room even. I get 5 groups of 3 and a single a left over. The 5 groups of 3 are going to come out front as an a to the 5th power. The single a that's left over is going to go under as an a. The b to the 5th, when I go to write down its prime factor tree, I get 3 b's followed by 2 b's. The 3 b's come out front as a single b. The 2 b's go back under and get multiplied out to be a b squared. So an answer for number 12 would be 2a to the 5th times b times the cube root of 2ab squared. Just in case it's not readable, 13 is the square root of 24x y to the 7th z to the 4th. I need a prime factor tree for 24, which is 2 times 2 times 2 times 3. Love doing prime factor trees on this calculator. I can do them by hand if I need. This is a square root, so every time I get 2, I get 1 out front. So for the 24, I get a 2 out front, and the 2 and the 3 that weren't pairs are going to get boxed and put back inside. The x is going to remain under my radical because there's only one of them. For the y to the 7th, it's a square root, so I need groups of 2, and I need 7 y's. I'm going to get 3 y's out front from the 3 groups of 2, which I'll write as a y cubed, and 1 y left over. And for the z to the 4th, I get 2 z's out front, which I'll write as a z squared, And no z's for under because there's nothing left over. I could have done the z's by dividing. So for an answer for 13, it should be 2x y cubed z squared times the square root of 6y. 14, which is 5 times the square root of 50, plus 3 times the square root of 2. 2 is a prime number. That second radical won't reduce. 50 is not prime. I'm going to do a prime factor tree for 50. Its prime factor tree is 2 times 5 times 5. So for the 50, it has a 5 out front, and I'm going to bring a 5 out front from the pair of 5s. From the square root of 50, it has a single 2 left over, so I'm going to put a 2 under the radical. So the first radical reduces the 5 radical to it had a 5 out front already, so I'm going to multiply the 5 that was out front by the 5 that I brought out front and get 25 square root of 2. The second radical is not going to reduce because 2 is a prime number. There's no pairs and it's prime factoring. Now I'm just going to add the 25 and the 3 and get 28 square root of 2 for my answer for 14. For 15, I'm multiplying, and they're both square roots. I'm going to multiply the 12 and the 10 and leave them under the square root. And then I'm going to do a prime factoring for 120. 120 is 2 times 60. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. So it's 2 times 2 times 2 times 3 times 5. It's a square root, so pairs go out front, singles go under. Just check my prime factor tree real quickly. 3 2s, a 3 and a 5. I get a 2 out front from the single pair of 2s, and under those 2 3s and 5s that I didn't box all go under and get multiplied, and 2 times 3 times 5 is 30. So my answer for 15 should be 2 square root of 30. For 16, I'm going to square both sides to get rid of the square root. On the left-hand side, you get x. On the right-hand side, I get 16. I checked all of these, so I might as well check by changing that x to 16 and make sure that both sides balance each other out, and they do perfectly here because when I simplify, both sides are 4. So that would be my answer for 16. That's my answer for 15. 17 can't be subtracted. Both radicals need to be reduced. I'll do a prime factoring for 18. 18 is 2 times 3 times 3. So the 5 square root of 18 part of this, it has a 5 out front, which I'm going to leave. The prime factoring tells me to bring a 3 out front and leave a 2 under. So the first piece is going to be 15 square root of 2. The second piece has a 50. The prime factoring for 50 is 2 times 5 times 5. For that second piece, it had a minus 2 out front. I'm going to leave the minus 2 out front. I'm going to bring a 5 out front, and I'm going to leave a 2 under because I have a pair of 5s. I get a 5 out front, and the single 2 stays under. The stuff that's in front, I'm going to multiply, and that gives me 10 square root of 2. Now I'm just going to go 15 minus 10 and get 5 square root of 2 for my answer to 17. No way I have room to do 18 here. 18 wants me to add 4 square root of 50 x cubed plus 8x square root of 2x. This second radical doesn't reduce. 2 is a prime number. It doesn't have any pairs, and there's a single x. I don't have to worry about it. But the first radical I need to worry about. The prime factoring for 50 is 2 times 5 times 5. So for the first radical, I'm going to bring a 5 out front and I'm going to leave a 2 under because I have a pair of 5s and a single 2. For the x cubed, it's the square root. I'm going to bring an x out front for the pair of x's, an x under for the single x. So this first radical is 20x square root of 2x. The second radical doesn't reduce at 8x square root of 2x. I'm just going to add the 20x and the 8x and leave the square root of 2x. And adding 20x plus 8x, that's just 28x. So my answer for 18 would be 28x square root of 2x. I've done a bunch of videos today, way more than I would like to, but I'm losing this technology and I like to do the work in my office. 19a, I need to write it as a radical. This is going to be the square root of x plus 3 to the first equals to 9. I don't need the index, nor do I really need the parentheses because the exponent is 1. So I can rewrite 19a as x plus 3 under the square root equals 9. And then I'm going to square both sides. On the left-hand side, when you square it, you just get the x plus 3. On the right-hand side, 9 squared is 81. I'm going to minus 3 from both sides and give myself x equal to 78. I'm going to check because I can and I should. I go to the original problem, change the x in the original problem to 78, pull out my technology because I like checking in my hand and by my calculator and make sure that when I plug that number in for x that both sides come out to the same number. If they don't, I've got a mistake or I have an extraneous solution, but it checks there. 2 problems left. B I can't do on one sheet of paper, but C I'll do first. It's way easier. And then I'll do B on its own sheet of paper. For part C, I'm just going to square both sides. The left-hand side, when I square it, gives me 3x plus 1. The right-hand side gives me 16. I need to minus 1 and divide by 3. When I minus 1, I get 3x equals to 15. And when I divide by 3, I get what I believe the answer is, which is x equal to 5. I should always check. I should take this 5 and plug it in for that x and see if the square root of 3 times 5 plus 1 equals to 4. Could use the times or parentheses there, but square root of 3 times 5 plus 1 is what my left side is. This gives me 4 equal to 4, so I'm perfectly checked. Just have to worry about this b, and the b is the problem where I probably could do perfect math, generate 2 answers, one will check and one doesn't. That normally happens for these kinds of problems. So last problem, 19b, gives me the square root of 2x minus 3 equals to x minus 3. I'm going to square both sides to get rid of the square root. On the left-hand side, when I square it, I just get the 2x minus 3. On the right-hand side, I have to create 2 parentheses and do the 4 multiplications. On the right-hand side, I have to do x times x, x times minus 3, minus 3 times x, and minus 3 times minus 3. The right-hand side is going to be x squared minus 3x minus 3x, those are for those, and then plus 9. The minus 3x's, if they had opposite signs, they would cancel, but because they have the same signs, I'm going to add those together and keep the sign negative. This is the grunge. Once we have an x squared, I know I need to solve by factoring, and I have to set it equal to 0 before I can solve by factoring. I like to keep the x squared term positive, so I'm going to get the 0 on the left-hand side by minusing 2x and adding 3 to the left-hand side. On the right-hand side, I lined up the x's. They're both negative, so I'm going to add those. The numbers are both positive, so I'm going to add those. Now I'm going to go to factor, and this needs to be minus and minus numbers. They need to multiply to 12. They need to add to negative 8. And that's going to be negative 2 and negative 6. The numbers in my parentheses are going to be negative 2 and negative 6, specifically because negative 2 times negative 6 is negative 12, and negative 2 plus negative 6 is negative 8. So the factoring on the left-hand side is x minus 2 and x minus 6. Once I get it factored, I set the inside of each parentheses equal to 0, and I do the algebra to isolate the x. For the x minus 2, I subtract 2. For the x minus 6, I add 6, should I say. And always before I check, I don't know that I really have solutions. I should check each separately. So I'm going to go to the original problem. The square root of 2x minus 3 equals x minus 3. I'm going to check the 2 and see if the square root of 2 times 2 minus 3 equals 2 minus 3. So square root of 2 times 2 minus 3. Left side comes out to be 1. Right side, 2 minus 3, comes out to be negative 1. The x equals to 2 is not a solution because I got junk. It can happen that neither checks. It can happen that both check. Usually one checks and the other doesn't. Let me over here check the 6. Going the square root of 2 times 6 minus 3 and see if that equals to 6 minus 3. So square root of 2 times 6 minus 3, which is 3. See if that equals to 6 minus 3. And it does, so that is a solution. When I write my answer, the best thing to do is only write the answer that checks, but I can write both and say that the one answer doesn't check. So either I would just say x equal to 6, I would say that's the best answer, or I could say x equal to 6, comma, x equal to 2 is extraneous or does not check. So that's everything that's going to be on the test. If you just master these 19 problems, maybe it's more like 21 or 22 problems when you add up the A's and B's. If you master these problems, that's everything that's going to be on the Chapter 4 test. That's all you're responsible for.